Welcome back to KrossUSA channel. Today we're taking you inside a state-of-the-art sawmill that represents the cutting edge of modern timber processing. What you're looking at here is a sophisticated operation that combines traditional craftsmanship with 21st century technology, and it's quite a sight to behold. Let's talk about what's happening here. The heart of this operation is the private 80 OW35ZM Jablonski sawmill system, a Polish-engineered marvel that's become increasingly popular in European timber operations. This isn't your grandfather's bandsaw, that's for certain. The Jablonski line represents decades of engineering refinement, designed specifically for high-volume production while maintaining the precision that quality lumber demands. The process begins at the log yard, where raw timber arrives from the forest. These logs, primarily consisting of pine, spruce, and fir, depending on the region and season, enter what's called the log sorting line. Now here's where it gets interesting. That 3D scanner we mentioned? It's working overtime, capturing thousands of data points on each log as it passes through. The scanner measures diameter, taper, sweep, and even detects internal defects that aren't visible to the naked eye. This scanning technology emerged in Scandinavian countries back in the 1990s, but it's only in the last 15 years that it's become affordable and reliable enough for widespread adoption. The difference it makes in lumber recovery is remarkable. We're talking about squeezing an additional 5 to 8% more usable lumber from each log compared to traditional methods. Once the scanner has done its job, the information feeds directly into the sawmill's computer system. The Private 80 system uses this data to position each log for optimal cutting. The OW35 in the model name refers to its ability to handle logs with a maximum diameter of 35 inches, though most production logs run between 12 and 24 inches. The logs move through on a series of conveyors and positioning mechanisms. Hydraulic arms grip and rotate each log, aligning it precisely according to the computer's instructions. The positioning needs to be accurate to within a millimeter, because even small errors compound as you're making multiple cuts. Watch how smoothly those logs rotate and shift. When the log enters the saw frame, you'll notice it passes through quickly but steadily. The blades themselves are running at speeds around 4,000 feet per minute, and they're making anywhere from 4 to 8 cuts in a single pass, depending on the log size and the desired lumber dimensions. The blades are specialty steel, manufactured to incredibly tight tolerances and maintained with laser-guided sharpening systems. In the old days, a sawyer would spend hours filing and setting saw teeth by hand. Now, automated systems keep these blades in perfect condition, replacing them on a schedule that maximizes both cutting efficiency and blade life. The cooling and lubrication system is another fascinating aspect. You'll see water spraying during the cutting process. This serves multiple purposes. It cools the blades, reduces friction, washes away sawdust, and actually improves cut quality by reducing the tendency for wood fibers to tear. The water is recirculated through filtration systems because modern operations need to be mindful of both environmental regulations and operational costs. After the primary cuts, the lumber moves to what's called the edger section. Here, the rough boards get their final sizing, with edge saws trimming each piece to standard widths. The waste material, those edge trimmings and sawdust, doesn't go to waste either. Most modern mills chip this material for paper production or compress it into fuel pellets. It's a far cry from the old days when sawdust piles just burned continuously outside the mill. The entire operation you're seeing here can process a log from the sorting line through to finished lumber in under 2 minutes. Compare that to historical sawmills from the 1950s, which might take 15 minutes per log, and you begin to appreciate the productivity gains. But it's not just about speed. The consistency and quality of the lumber produced by these automated systems exceeds what was possible with manual operations. Every board meets precise dimensional standards, which is exactly what modern construction and manufacturing require. This facility represents an investment of several $1 million in equipment alone, not counting the building and infrastructure. But for a high-volume operation processing 50,000 to 100,000 logs annually, the payback period is surprisingly reasonable, typically 5 to 7 years. The key is maintaining steady production and minimizing downtime, which is why you'll see these operations running 2 or even 3 shifts a day. What we're witnessing here is the evolution of an industry that's been around for centuries, now enhanced by technology that our predecessors couldn't have imagined, yet still fundamentally doing the same job, transforming raw timber into the lumber that builds our homes, our furniture, and countless other wood products we use every day. Now we're heading down to Brazil to visit Copatti Agro-Industrial, a company that's been making waves in the South American timber industry for over 3 decades. Founded in 1989 in the southern state of Paraná, Copatti started as a small family operation and has grown into one of Brazil's leading processors of plantation-grown pine and eucalyptus. It's a story that reminds us how the timber industry can sustainably thrive when done right. What you're seeing here at Copatti's facility is a fully integrated operation. The logs arriving at this mill come from the company's own managed forests, harvested at optimal maturity, which for these pine species is typically between 15 and 25 years. That's remarkably fast compared to the 50 to 80 years it takes for similar species to mature in colder climates. The longer growing season and abundant rainfall in southern Brazil create ideal conditions for rapid timber growth. Let's walk through their process step by step, because every stage here tells a story of efficiency and planning. The logs enter the mill yard, where they're organized by diameter class and quality grade. You'll notice they're kept wet, either under sprinklers or in log ponds. Keeping logs moist prevents end checking, those splits that develop when wood dries too quickly. It also makes the wood slightly easier to cut and helps preserve quality until processing. The debarking process is the first major step you're witnessing. Copatti uses ring debarkers, massive machines that grip the log and rotate it against fixed cutting edges that strip away the bark in a continuous spiral. The bark falls into collection systems below and gets transported to the company's biomass boiler. Nothing goes to waste in a modern mill. That bark, which used to be considered refuse, now generates steam for the dry kilns and electricity for the facility. After debarking, logs move to the primary breakdown line. Copatti runs what's called a quad saw system for their main production line. As the log passes through, the quad saw makes 4 simultaneous cuts, essentially cutting the log into 4 quarters, with remarkable speed and accuracy. The geometry of the cuts is controlled by laser positioning systems that calculate the optimal breakdown pattern for each log based on its diameter and taper. Here's where things get particularly interesting from a technical standpoint. The quad saw doesn't just cut straight through. Modern systems like Copatti's use what's called curved sawing, or optimized breakdown. The saw head can actually adjust its position slightly as the log passes through, following the log's natural shape to maximize the amount of clear, high-quality lumber recovered from each piece of timber. The cants, those squared sections that come off the quad saw, then proceed to gang saws or multi-blade edgers that break them down into individual boards. Watch the speed here. These boards are moving through at rates of about 200 to 300 feet per minute. The coordination required between the various conveyors, positioning systems, and saws is orchestrated by a central computer that's monitoring dozens of variables simultaneously: feed speed, blade position, board thickness, moisture content, even the current load on the electric motors. One detail that often goes unnoticed is the optimization software running behind the scenes. Every board that comes off these saws passes through scanning stations that grade it for quality, measuring knot size, grain patterns, and defects. The system then makes real-time decisions about where each board should go: premium grade for clear appearance lumber, standard grade for construction, or perhaps routed to the finger jointing line, where shorter pieces get spliced together into longer boards. Copatti's operation includes an extensive drying facility, and this is where patience meets technology. Those green boards coming off the saws contain anywhere from 60 to 120% moisture content. Yes, you heard that right. The wood can actually hold more water by weight than the dry wood fiber itself. The dry kilns you're seeing are massive chambers, each capable of holding several truckloads of lumber. The drying process takes anywhere from 3 days to 3 weeks, depending on the thickness of the lumber and the species. Modern kilns are marvels of environmental control. They precisely manage temperature, humidity, and air circulation to dry the wood as quickly as possible, without causing defects like warping, splitting, or case hardening, where the outside dries faster than the inside. After drying, the lumber goes through what's called the planer mill. Here, rough-sawn surfaces get smoothed to precise dimensions. The planers at Copatti are running at high speeds, with multiple cutting heads that can surface all 4 sides of a board in a single pass. The machines remove just enough material to create smooth, uniform surfaces while maintaining dimensional accuracy within a 32nd of an inch. The difference between rough-sawn and planed lumber is dramatic. What looked rustic and rough comes out the other side smooth as glass. The final stages involve sorting and packaging. Automated sorting systems separate lumber by length, width, grade, and sometimes even by end use or customer order. The packaging lines bundle boards with metal strapping, wrap them in protective plastic, and stack them on pallets ready for shipping. Copatti ships throughout South America and exports globally, with containers heading to markets in North America, Europe, and Asia. What's particularly impressive about operations like Copatti is the integration of forestry, manufacturing, and logistics. The company manages every step from seedling to finished lumber, with computerized inventory systems tracking individual logs from forest to final product. This level of control ensures consistent quality and allows for incredible customization to meet specific customer requirements. The Brazilian timber industry has faced its share of challenges and criticism over the years, often lumped in with legitimate concerns about rainforest preservation. But companies like Copatti represent a different model entirely: sustainable plantation forestry that actually reduces pressure on natural forests while providing economic opportunity and high-quality lumber products. The southern Brazilian pine plantations now cover millions of acres that were previously degraded agricultural land, representing genuine reforestation and carbon sequestration. For those of us who've spent our lives around lumber and woodworking, seeing operations like this is both humbling and inspiring. The scale is enormous, yet the attention to detail rivals the finest craftsman's workshop. Every decision, from forest management to final packaging, is optimized for quality, efficiency, and sustainability. It's industrial forestry at its finest. Let's travel now to the Baltic region, specifically to Latvia, where we'll visit Gaujas Koks, one of Northern Europe's most advanced integrated wood processing facilities. The facility you're looking at produces an astounding 350,000 cubic meters of processed lumber products annually. To put that in perspective, that's enough lumber to frame about 15,000 average-sized homes every single year from this one facility. The Cross-Laminated facility is particularly noteworthy because it's not just a sawmill, it's a complete value-added processing center. What you're watching here is the lumber processing line. But this complex also includes kiln drying facilities, planing mills, a pressure treatment plant commissioned in 2015 with a capacity of 100,000 cubic meters, and most impressively, a cross-laminated timber production line installed in 2016 that can produce 50,000 cubic meters annually. That CLT line is particularly significant, representing the future of engineered wood products. Let's start with the basics of what's happening on the sawmill floor. The logs entering this facility are primarily Scots pine and Norway spruce, the workhorses of Northern European forestry. These species have been harvested in this region for over 1,000 years, used by everyone from Viking shipbuilders to medieval craftsmen. The difference now is the precision and efficiency with which we can transform these logs into usable lumber. The primary breakdown system here uses a combination of bandsaws and circular saws in what's called a curve sawing configuration. The technology allows the saw line to follow the natural curvature of each log, maximizing the recovery of clear, straight lumber. Watch the log handling system carefully. You'll notice the logs are positioned and rotated with incredible precision. The equipment uses servo-hydraulic controls that can position a multi-ton log to within a millimeter of the target position in just seconds. The operators you might glimpse in the control room aren't manually controlling each movement. They're monitoring automated systems that process logs based on pre-programmed optimization algorithms. The edging and trimming operations happen in rapid succession after the primary cuts. Multiple saw stations work in coordinated sequence, each removing another increment of waste material and bringing the lumber closer to final dimensions. Now let's talk about that pressure treatment facility, because it represents a significant investment and an important part of the operation. Pressure treatment forces chemical preservatives deep into the wood structure, protecting it from rot, insects, and fungal decay. The process involves placing lumber in massive steel cylinders, creating a vacuum to remove air from the wood cells, then flooding the cylinder with preservative solution under high pressure. This forces the chemicals deep into the wood, far beyond what surface application could achieve. The cross-laminated timber line is perhaps the most exciting part of the KrossUSA operation. CLT, for those unfamiliar, is an engineered wood product where layers of lumber are stacked crosswise and glued together under pressure to create large structural panels. The beauty of CLT is that it allows wood to be used in applications previously reserved for steel and concrete, mid-rise and even high-rise buildings. There are now CLT structures up to 18 stories tall, and the technology is revolutionizing sustainable architecture. The production process for CLT is fascinating. Individual boards are first planed to precise dimensions, then arranged in layers with each layer oriented perpendicular to the adjacent ones. This cross-lamination gives the panels dimensional stability and strength in all directions. The layers are bonded with polyurethane adhesives applied in precise patterns. Then the entire assembly goes into a massive hydraulic press that can generate thousands of tons of pressure, compressing the layers together while the adhesive cures. The finished CLT panels are then trimmed to size, and CNC machines cut precise openings for windows, doors, and surface penetrations. A complete wall section, including openings, can be fabricated in the factory and shipped to the construction site ready for installation. Back in the main processing area, the integration of all these operations is what makes KrossUSA so efficient. Lumber that doesn't meet the standards for CLT production goes to other product lines. Short pieces that would be waste in a traditional mill get finger-jointed into long lengths. Lower grades become pallets or packaging materials. Sawdust and chips feed the facility's biomass boilers. Bark becomes mulch or fuel. The efficiency of resource utilization approaches 98%, meaning virtually nothing goes to waste. The drying kilns here run continuously, processing thousands of cubic meters of lumber every week. The facility uses waste heat from the biomass boilers to supplement the kiln heating systems, creating synergy between different parts of the operation. The Latvian climate, with its cold winters and mild summers, actually provides natural cooling for much of the year, reducing the energy needed for certain processes. For anyone who remembers the lumber industry of the 1960s and 70s, operations like KrossUSA represent an almost unimaginable level of advancement. The combination of traditional forest management, cutting-edge processing technology, and value-added manufacturing creates a 21st century forest products industry that's both economically viable and environmentally responsible. It's a model that points the way forward for sustainable timber production worldwide.